Have you ever wondered what those upward curving extensions at the tips of aircraft wings are? Well, let's take a closer look. Those are known as winglets, vertical extensions of the wingtips that serve a very important purpose. They're not just there for aesthetics, though they do add a sleek touch to the aircraft's overall appearance. Winglets are all about improving the aircraft's performance. They do this by reducing the drag caused by vortices, which are swirling air currents created by differences in air pressure on the upper and lower wing surfaces. If you're picturing a mini tornado spiraling off the wingtip, you're not far off. These vortices can create a lot of turbulence and drag, which slows the aircraft down and burns more fuel. But here's where the magic of winglets comes into play. These vertical extensions act as a barrier, preventing the high-pressure air below the wing from mixing with the low-pressure air above it. This significantly reduces the strength of the vortices and thus the drag. So when an aircraft equipped with winglets soars through the sky, it does so with greater efficiency. It uses less fuel, can fly further, and does it all while looking incredibly stylish. These sleek, upward curving extensions are more than just decorative. They're highly functional and they're called winglets. Now that we know what winglets are, let's delve into how they work. Winglets, as their name suggests, are little wings that extend vertically from an aircraft's wingtips. But they're not there just for show. Their main job is to combat a phenomenon known as wingtip vortices. These are swirling tornadoes of air that form at the wingtips as the aircraft cruises through the sky. They're caused by the pressure difference between the upper and lower surfaces of the wing. Imagine the aircraft wing as a battlefield, with high-pressure air on the bottom trying to invade the low-pressure territory on top. The wingtip is the only place where these two opposing forces can meet and mix, creating these turbulent vortices. This is where our winglet superheroes come into the picture. Winglets act like a barrier, a wall if you will, that prevents the high-pressure air from rolling up and around the wingtip to the low-pressure area. By blocking this pathway, winglets reduce the strength of these vortices, subsequently reducing the drag they cause. But the magic of winglets doesn't stop there. In addition to reducing drag, they also produce a small amount of lift, similar to the main wings. This is because they are angled slightly towards the sky. This extra lift pushes the plane upwards, counteracting some of the downwards force created by the vortices. All these factors work together to create an aircraft that is more efficient. With less drag, the aircraft can fly faster or use less fuel for the same speed. The extra lift provided by the winglets also helps in increasing the aircraft's range, enabling it to fly longer distances without refueling. So, in essence, winglets are like aerodynamic superheroes, battling drag and amplifying efficiency. Winglets come in different shapes and sizes, each designed to optimize performance. You might think of winglets as one size fits all, but in the world of aviation, winglet design is as varied as the aircraft they adorn. Let's start with blended winglets. These are usually found on Boeing 737, 757, and 767 aircraft. Their design is such that they curve outward, blending seamlessly into the wings as though they are a natural extension of the aircraft. This smooth integration reduces drag and boosts performance. Next up, we have split scimitar winglets. These are unique in that they consist of two distinct parts, with the lower part angled downward. This special design aids in further drag reduction. The Boeing 737 Next Generation and 737 MAX are the proud bearers of these winglets. Then there are the sharklets. As the name suggests, these winglets bear a striking resemblance to the fin of a shark. They are vertical extensions that give the Airbus a 320 family, a 320 Neo family, and the A350 their distinctive appearance. These shark fin-like shapes are more than just for show. They contribute significantly to the aerodynamic efficiency of the aircraft. But why so many different designs, you might ask? Well, each type of winglet is designed to optimize the performance of the specific aircraft it's fitted to. Factors such as the size, weight, and intended use of the aircraft all play a role in determining the most effective winglet design. No matter the design, all winglets serve the same purpose: to make our flights smoother and more efficient. So the next time you're admiring the sleek curves of an aircraft's wings, remember the humble winglet working tirelessly to get you to your destination more efficiently. So, what does all this mean in the real world? Well, It's quite straightforward. The science and engineering behind winglets translate into tangible benefits that affect our everyday lives, particularly when we fly. The key impact areas are fuel savings and range extension. Let's talk about fuel savings first. Air travel is notoriously fuel-intensive, and any technology that can help reduce this consumption is a game changer. That's where winglets come in. By reducing drag, they allow aircraft to fly more efficiently, which translates into less fuel burned. This not only saves airlines billions of dollars in fuel costs, but it's also a win for the environment, contributing to a reduction in carbon emissions. Now let's move on to range extension. This is another significant real-world impact of winglets that benefits both airlines and passengers. By improving an aircraft's aerodynamic efficiency, winglets enable planes to fly longer distances without refueling. This means airlines can offer direct flights over longer routes, providing a more convenient travel experience for passengers. A great example of this is the Boeing 747-400. When Boeing introduced canted winglets on this model, it saw a 3.5% increase in range. That might not sound like much, but in aviation terms, it's a big deal. This increase meant that the 747-400 could fly almost 200 additional miles on the same amount of fuel. This opened up new possibilities for non-stop long-haul flights, revolutionizing the way we travel. But that's not all. The benefits of winglets extend beyond fuel savings and range extension. They also improve aircraft stability, reducing turbulence and making your flight smoother and more enjoyable. So the next time you board a flight, take a moment to appreciate those winglets. They're saving fuel and extending your plane's range. To wrap up, let's summarize why winglets are so crucial in modern aviation. These humble vertical extensions at the wingtips of aircraft are the unsung heroes of aero engineering, making significant contributions to the efficiency and performance of flight. Firstly, winglets serve a simple yet profound purpose. They cut down on drag. By reducing the formation of wingtip vortices, which are caused by differences in air pressure on the upper and lower wing surfaces, winglets minimize drag and make flight smoother. It's a bit like parting the seas of air, allowing the aircraft to slip through with less resistance. Secondly, they are marvels of design. From the gently curved blended winglets, the two-part split scimitar winglets, to the shark fin-like sharklets, each type of winglet is meticulously engineered for specific aircraft models, enhancing their performance. They are not just aesthetic additions, but functional extensions that contribute to the overall aerodynamics of the aircraft. Moreover, the benefits of winglets extend beyond the flight experience. They play a crucial role in fuel efficiency, leading to significant fuel savings. In an era where sustainability and fuel economy are of paramount importance, the role of winglets cannot be overstressed. They also extend the cruising range of aircraft, as seen with Boeing 747-400, which experienced a 3.5% increase in range due to its canted winglets. But the impact of winglets doesn't stop there. They also contribute to noise reduction and help in reducing the carbon footprint of aviation, making them integral to the future of sustainable flight. Winglets, the unsung heroes of aviation, continue to soar high, making our flights smoother and more efficient. So the next time you see those upward curving extensions, you'll know just how important they are.